Good morning and welcome to Math 10C, Unit 1, Lesson 1. And this is Powers and Roots. Part 1. Okay, so we have to know a few things about vocabulary, and one of them is factors. So what are factors? Factors are numbers that multiply to create a product. Well, what is a product? That is the answer of multiplying numbers. Okay. So we have to take a look and see what kind of numbers we're going to deal with in this unit. We're going to be dealing with, of course, rational numbers, irrational numbers, and rational numbers have the fractions and decimals. Then we deal with integers, which are positive and negative numbers. Then we deal with whole numbers, 0 to positive infinity, and we deal with natural numbers, which is 1 to positive infinity, also called our counting numbers. So when we take a look at our example here, the whole number 6 is exactly divisible by the numbers 1, 2, 3, and 6, and by no other whole numbers. So it says these then are the factors. Okay, so those are your factors. So how could you find the factors of 6? Well, you make a factor chart, a factor T-chart. So we create a T, we put the number 6 on top, and now what we do is we find the numbers that multiply to give us a 6. Well, we always start with 1. 1 times the number itself, 1 times 6, and the next one will be 2 times 3. All 4 numbers are the factors. If there's any repeats, when we list our factors, we only list the repeated numbers once. Okay, so we're going to do the same thing with the number 15 and the same thing of the number 24. So 15, I'm going to make a factor T-chart, and I've got 1 times 15, 3 times 5, and that's all. So my factors are 1, 3, 5, and 15. If they want us to put them in a set, we would put these curvy brackets around them. Those are called braces. This is now called a set of factors when you put them in those curvy braces. Okay, and that's different from a list. So a list, I'll put the factor list on number 24 here. So the first thing we're going to do, though, is do a factor T-chart of 24. 1 times 24, 2 times 12, 3 times 8, and 4 times 6. So now if I just make a list of my factors, I would have 1, 2, 3, 4, 6, 8, 12, and 24. You list them from smallest to biggest. So smallest to greatest. Okay, they might say least to greatest. All right, let's take a look at the next example. So it says in each case, determine the number of factors that are given for each whole number. Well, again, all we're going to do is a factor T-chart. So a factor T-chart with 3, 1 times 3, your factors are 1 and 3. 10, we have 1 times 10, 2 times 5. Our factors are 1, 2, 5, and 10. Well, what numbers multiply to give us a 1? The only thing that multiplies to give us a 1 is a 1, and it's going to multiply by itself. So the only factor is 1. It's identical. It's multiplying by itself. And how many factors? Because we want to find the number of factors. So first of all, we're going to list our factors for each one, and then we're going to state the numbers. So for 7, again, a factor T-chart, 1 times 7. Our factor list is 1 and 7. 18, our factor T-chart, 1 times 18, 2 times 9, 3 times 6. So our list would be 1, 2, 3, 6, 9, and 18. Now we're going to count how many in each list we created. So we created 2 digits on this one, so there are 2 factors here. If we look at the list on B, we had 4 factors, 4 different numbers. If we look at C, again, we only have 1 digit that creates a 1. What creates a 7? 2 different digits, 1 times 7. We're talking about the number of digits here. And if we take a look at 18, we have 1, 2, 3, 4, 5, and 6. So 6 digits, 6 numbers identify for their factors. Now we're going to talk about prime and composite numbers. So this is part B. Part A is our factors. And now we're on part B, prime and composite numbers. So first of all, what is a prime number? If you remember from before, a prime number is a number that is defined as having only exactly 2 factors. And it's always 1 and the number itself. Okay? So only 2 factors, and we need to state something in there, 2 different factors. And that's going to be discussed in our one little star here. We're going to put a star beside the third or fourth sentence here in this statement. So our second or third statement says a composite number, on the other hand, is a whole number that has more than 2 factors. So if we were to look at the numbers above in class example 2, the ones that have only 1 in itself, the prime numbers would be a 3 and a 7, because we want different factors. 1 doesn't include that, because 1 only includes 1 times itself, and they're identical factors. They don't fit that description. So that's why 1 is neither prime nor composite. So that's something we got to remember about the digit 1. It is neither prime nor composite. But looking at composite numbers, they have more than 2 factors. So if we look at 10, there's more than 2 factors. We have 4 factors. If we look at the number 18, there were 6 factors. Okay, so those would be composite numbers. In this course, we talk also about the number 0. 0 is defined as having no factors, but it is always considered positive. Okay, so it's considered to be a positive value. Now what we're going to do is we're going to list the first 10 prime numbers. So again, the number 1 is not a prime number. The only even prime number is the number 2. So that is the only even prime number. Every other prime number will be odd. Okay? So we have the numbers 2, 3, 5, 7, 11, 13, 17, 19, 23, and 29. These dots on the end mean that that pattern continues forever. Now, what are the number values? What would our range be here? Well, those are the numbers 2 to 29. Okay, so that's where our first 10 prime numbers are. Okay, the first 10, they're within the numbers 2 to 29. All right, turn your page, please. Okay, class example 3, we are now going to classify each of these numbers as prime or composite. So again, start dividing by 2. So even numbers, they can easily be divided by 2, which means they have more than 2 factors. Okay, so if we look at 46, it's an even number, so it's going to be a composite number. Number 37, it is not even, it is odd, same as the other rest of these numbers, all 4 of them, but we have to decide whether or not they are prime or composite. So we just start dividing, and you divide by every number smaller. So if I take the number 37, I'm going to start dividing because it's odd. I'm going to divide by 3, then I'll try 4. It doesn't end in a 5, so really you can skip trying to divide by 5. You can go to 6, 7, 8, 9. You don't have to divide by 10 because it doesn't end in a 0. It's not a double digit, so you can skip 11. You don't divide by 11. 12, 13, 14, etc. And you'll continue dividing. None of them will work on this one. So this guy is a prime number. Okay? 39, though, however, if it's an odd number, you're going to start dividing by 3 and see if you can get an even number. And 39 does divide by 3 evenly, so it's a composite number. However, the number 101 and 103, if we start dividing again by all these odd numbers, we start dividing by them, we're going to find nothing works. So they are both considered prime numbers. Okay, now we're going to talk about prime factors. So that's our section C here. So prime factors of a whole number are the factors of it which are the prime ones only. So if I take example that we started with the number 6, we listed 4 different factors. So here are the 4 different factors. Of that factor list, we are only choosing the prime ones. The prime ones are 2 and 3. Now, how can we list the prime factors? There's a couple different ways that we can create prime factors. And the only way to do that, we're going to discuss in prime factorization. So what we know right now is to make factor charts. So again, you always start by making a factor T-chart. Okay, that's how we're going to start. So if I have the number 12, I'm just going to put it over on the right-hand side so I have more room. If I have the number 12, I'm going to multiply 1 times 12, 2 times 6, 3 times 4. Once the numbers get really close together or identical, they're going to reverse. So then they just start repeating themselves. So that's how we know we're done. So 12, the factors are 1, 2, 3, 4, 6, and 12. Again, we're always listing them least to greatest. And now from that list, we're going to select the prime numbers. Well, we know 2 is prime and 3 is prime. 4, 6, and 12 can all be divided. They're even. They can all be divided by 2, so they are not prime. However, the number 2 and 3 are the prime numbers. So now we want to list it as a product of prime numbers. Well, what do we know about the number 4? Well, the number 4 can be broken down into 2 times 2. So if we were to write it, we want to use only the number 2's and 3's because those are our prime numbers that we discussed from the list above. So since we use those prime numbers, how can I create the number 12? Well, I would have 2 times 3. That gives me my 6. But if I times 6 by 2, I get 12. So I'm going to put it least to greatest. So this is my order I would list them in. I would have 2 times 2 times 3. Product means it wants to see the multiply signs. Okay, so it wants to see the multiplication signs. Or in exponent form. So because we have 2 2's, we could also write this like this. 12 equals 2 squared. There's 2 2's times 3. Okay? We're now going to do the same thing with the number 16 as an example. We're just going to do another example, and we're going to use 16. Now, we'll use that after we try the prime factorization. So first of all, we have prime factors, and now we're going to talk about prime factorization on our next section here. So it says every composite number can be expressed as a product of prime numbers. This is called prime factorization of those numbers. So we're going to talk small numbers, they say here, like numbers like 12 and 6, 18. They can be done mentally in your head or by a T-chart. Whoopsie, or a factor T-chart. Okay, so you can make your factor T-chart, but for large numbers, we're talking larger numbers, so 2 and 3 digit numbers, anything over 24 basically, something that you can't make a quick list about, you would use a division table or a tree diagram. Now, these are two examples for the prime factorization of 48. And you're probably wondering, well, let's take a look at the tree diagram first. Here they started with the numbers 6 and 8, and then they broke each of those numbers down. And they kept dividing if the number was even, dividing by 2, if the number was odd, dividing by 3. So we're going to notice, what did it end up with as prime factors? These lower numbers here are going to be all the prime factors. So 48 is going to have 4 2s and 1 3. So down here we see 4 2s and 1 3, 4 2s and 1 3. Okay? Now, how would they do that with a division table? Well, normally we see long division like this. We would see 48, divide it by 2, we'd get a 2, we put a 4, this guy, the 8 comes down, 2 times 4 is 8, we get 0. So that's called long division. That is different than a division table. A division table, this sign, the division sign, is upside down, okay? It looks like an L, and that's how we start. So I'm going to use a different number, the number 16, and I'm just going to show you how to use the division table. So if I use the number 16, I would start with my number 16. I would draw an L, so 16 is divided by 2. The answer of that division goes below, so 8. Then I'm going to draw another L, okay? So 8 can divide by 2 evenly and get a 4. Okay, 8 divides by 2 and becomes a 4. 4 can also divide by 2 and become a 2. Well, 2 can also divide by 2 and become a 1. So with the division table, you always want to make sure that you get down to a 1. That's how you know you're done. Now, 1 is not considered prime. So where are our prime numbers located? On the left-hand side here. So those are where our prime numbers are located. So for the number 16, I would write my prime factors are 2 times 2 times 2 times 2, or I would say 2 to the 4th power. Okay? So that's how you would do division tables, always reducing to the digit 1. All right. The different forms, this is called repeated multiplication. Or they could also call it expanded form. Whereas on the right-hand side here, this is called exponential form. It's a quick shorthand way of writing the same numbers, but you use less space and it doesn't take as long. So literally, the exponent number, that little baby number on the top right, that's telling you how many of the factor numbers there are of the base. Okay, so it's saying you have 4 2s. All right, turn your page. Last page of our notes here. Okay, here's the example. We're going to do this one by a division table. So because the number is even, I'm starting with the number 2772. I'm going to draw my division letter L. And this guy we know divides by 2. Okay? So I'm going to grab my handy dandy calculator and I'm going to divide that guy by 2 and I'm going to get 1386. And that guy's also even, so he's also going to divide by 2. You do not have to show the divide signs. I'm just showing you what I'm doing literally. 1386 will divide by 2 and become 693. This one is odd. So if it's an odd number, we can no longer divide by the number 2. So we're going to now try to divide by the number 3. And yes, dividing by the number 3 works. Works meaning you get an even number, I shouldn't say an even number. You get a whole number, not a decimal number. So now 693 becomes 231. We draw our division L. Again, it's an odd number, so it should divide by 3. And if it doesn't, I will try another number. I would try 7. I would try 11. If it doesn't end in a 5, you don't need to try 5. It won't work. Okay, so 231 does divide by 3, and now look what I get. It becomes a 77. Well, I have a double digit there. What do you notice about double digits? Well, they will always divide by the number itself and 11. So 77 is going to divide by 7, and I'm going to get an 11. And then 11 will divide by 11 and become my 1. Because remember, we're always reducing down to a 1 on the bottom. And now where are my prime numbers located? On the left-hand side. So to write it as a prime factorization, you would say 2772 becomes 2 times 2 times 3 times 3 times 7 times 11. That is your expanded form. In your exponential form, 2 squared times 3 squared times 7 times 11. Again, our exponent numbers, these numbers here are telling you how many of each of the factor numbers you have. Okay, last example in this lesson. We're going to use a tree diagram this time instead of a division table. And we're going to see what this big number divides by. We're going to get a really big hint, the fact that it ends in a 0. If it ends in a 0, always start by dividing by 10. Start dividing by 10. So 3, 3, 2, 5, 0, make my spokes. I'm going to divide by 10. And that's going to give me 3, 3, 2, 5. And now I make spokes from each number if they reduce. Can I divide them? You bet I can. This one ends in a 0. If it ends in a 0, start with 10. And if 10 doesn't work, then you go to 5. So this guy is going to divide by 5. And we get a 2. Now we're going to take 3, 3, 2, 5, and it ends in a 5. So again, anything ending in a 5, you're going to divide by 5, and that's going to become a 6, 6, 5. Again, that number ends in a 5, so we're going to divide by 5 again, and we're going to get 133. This is an odd number. So odd numbers, we're going to try dividing by 3. I tried 3, 3 didn't work. 5, it doesn't end in a 5, so I'm not going to try 5 because I know 5 won't work. So then I go to the next odd number. I try 7. And believe it or not, 7 works. 7 times 19. Now, 19 is a prime number, and so is 7, which means they don't reduce lower. So now we have our prime factorization, which becomes all of our prime numbers on the bottom. I have 5s, and then I've got a 2, I have a 7, and I've got a 19. So all of them are different. So we're going to list the ones smallest to biggest. So a 2 is our smallest. Then I'm going to list my 3 5s. They're the next biggest number. Then I'm going to list my 7, and then I'm going to list my 19. And again, that is your expanded form. In exponential form, we would have 2 times 5 cubed times 7 times 19. This concludes Lesson 1 for Unit 1.